record this session.
Oh, good.
Yeah,
Actually, can I also record? Is that possible for me to do it as well?
You can record. I don't have to resend it to you. You can record. You don't have to send. Yeah.
Please ask the host to give you permission to record. Maybe there's a setting or something.
I can fix that. So what is permission? Multiple participants share or what's green? Is this does that allow you to record?
No, not yet.
Probably another advanced setting option. One participant can share participants option. Any other? Who can start sharing when someone else is sharing?
It's not a big deal if it doesn't work. That's okay.
Well, I send it to you. Okay, I record
okay,
that.
Great.
I send
that sounds
to you,
good.
And I will fix that problem next time.
Okay.
So basically, we are talking about to choose a set of unit. Okay, the set of unit vector, a unit vector. A set of unit vector, doesn't matter, unit vector, the unit vector. Unit, or sometimes called directional, because that primarily gives the act as indicator of a particular direction. Could be north, could be southeast, or could be anything between the this fixed direction. There's directional unit vector. It is vector, right? After all, it is vectors, unit vector. So when we're talking about the whether these set are independent or not. So primarily, so basically, this is just adjective. Okay, so this is adjective. So we are talking about whether these set vectors are independent or not. Okay. Now we have to. Do you have any idea before we go further? Do you have any? What does mean that independent? So, for example, you are independent from a parent now because you got your income. So I mean, but what does mean independent? Independent.
Well, my first guess would be, and I don't know if this is correct, but that there's if something is dependent, then sort of the mutual information between the two elements is very, very high. So one is almost a function of the other.
So they have constraint. Do you agree? They have constraint. For example, if I give example, let's talk about the function first. Say if y equal to the 9.8, for example, and x can be anything in the real number. Okay. So question is A is independent of x?
Is A independent of x, or is
Y independent of x? I just drew this diagram.
No, not if it's a function.
So means it's dependent. Do you mean it dependent?
It is dependent.
Okay.
Yes, it is dependent.
That's something interesting occur from this starting point. So this is y. Do you agree? This is y.
Yep.
So if this is a 10, or precisely this is 9.8, right? Is a particular point there, and this is x. So this graph will be look like this. Okay, I can use a purple one or whatever. So this means y is a constant. Do you agree? The first question means y is a constant. Do you agree? And x is variable. X can be both positive or negative because a real number. So x can be the number anywhere. Okay, if we go beyond this graph, can you see? So x can be everywhere. Okay. Does that change affect the y value?
No. So I suppose in that case they are independent.
Okay. Dependent or independent? It's just common sense. Dependent or independent? Okay.
Independent.
Independent. Okay. For example, in the perfect independent family, for example, so your income is this. Okay. Your income is this, independent of other members whose income is over or dead. Okay, doesn't matter.
Yes.
Your income is there. Nothing to do. Independent. That is ideal. Okay.
Yes.
So makes sense. So in that case, conclusion is simple, right? In this case, y is independence. Y is independent. Okay, independent from y, from from X. Okay, so that is a common sense. That's common sense. Now the second question, second example, if I go to second example, if Y equal to say is a 2X. Okay. Now in this case, is X, and again, X can be any value in real number. So in this case, is Y is dependent on X or independent?
It is the direct function of X. It's just 2 times X, so it is dependent.
It is dependent, okay?
Yes.
Not just dependent. If you draw you will surprisingly see that if you put this number here, you will see that it's not only dependent, it's also linearly dependent.
Okay.
Make sense? That makes
yes,
sense?
Yes.
That's
yes,
yeah,
definitely.
so therefore you can count Y is linear, put as a adverb here, adverb. No, not, it's adverb, yeah? It's adverb, yeah.
Linearly dependent. Yes.
It's linearly dependent, right?
Yep.
So that gives you some ideas. So what is the origin of these two words play? Now, unfortunately, when students choose algebra, okay, the teachers or lecturers always go to some very abstract definition. Okay,
Yes.
and then they jump to from nowhere and say, well, let's consider. Okay, let's go to examples and let's go to the typical. This is typical algebra, linear algebra questions. So they are given. So they're given these vectors. They're given vectors. Okay, so just can we confine the two dimensionals. One, and that is and two, and one, and this and anything else. Can we just put a two? We start from two. Okay, so two vectors. Given that,
Yep.
so that's a u1. This u1. That's a u2. And so the questions are U1 and U2 linearly independent. I put the two linearly independent. Can you see the emphasis? It's independent. Independent. Do you have a clue? Do you how to solve this problem? So you got two vectors. So there's two vectors, right?
I guess they would be dependent if one is just a scalar product of the other.
It is conditional. Or you talk a product, okay? Oh, by the way, if you talk a product, can we just go further? Can we leave this question alone for a while?
Okay.
This adverb is very important. Let's go to example 3. Okay, we have to, so don't mix with linear. So this is it's constrained. Okay, dependent can be nonlinear. Okay, that is something, that's message we have to explicitly specify here. In this third example, if y equal to say x squared plus so even called ex. Okay, ex. Okay. So and again, x can be any number in a real number set, and so then the question is: is A independent? What is question? So what can we say? Is y is dependent on x in first place? Y is dependent, sure, for sure, okay, because x change will constrain the change of y. So therefore, y to some extent is depend or controlled by x. So that's of course this relationship is quite is subjective. Do you understand? If you solve the x, for example, in principle, if you solve the x, and that will become the function of y. Do you agree? So therefore, you say x will be dependent on y. Can you see? So this,
you can flip it.
That you can flip that. So this dependence is mutual. Okay, it's not mutual. It's just arbitrary calling. Okay, it's sound. You depend on somebody. You say, oh, I'm not independent. Okay, but actually that guy is also depend on you. If you do you understand?
Yes.
Do you understand?
Yes.
So that's the wording. So that's for definitely is dependent. Okay, dependent.
Yep.
But can we put the adjective, not adverb, linear here? It's linear. Can we do that linearly in this case?
It is not.
It is not.
Linearly.
It is
Yeah.
not. So basically, when you talk about independent, then they have you have many choices. Okay, this is non-linear, so non-linear, and non. So is dependent non-linearly. So I put the non-linearly. So it's the linear is very special group. Okay, or category, and that is that is a subject we study in the linear algebra. Okay, if you say let's talk about non-linear algebra, okay, we're throw all our rows into a basket. we have to divide. We do have to divide all these rows, like even the sum and the product from scratch. Okay, that's what we want to do. I don't want to try this beautiful, elegant building called linear algebra. So this is so non-linear. So I make that difference. So therefore, you are right. You will see this one. You have to assume that what you're talking. You have to make sure what are you talking about. It's the linear is very restrict word. Okay. So let's just go to a new page to talk about. So if you have there's another example, example 4. So given I just write down given there's 2. So but u1 equal to say equal to, so did I say 1 0 1 0 1 and u2 equal to, I forgot the number, just put copy the number 2 1, yeah, 2 1 2 1. So the question is, are they dependent or independent? We're dependent on the condition. Do you agree? So we can hardly make judgment, okay, without a criteria, okay. So that is we have the introduce. We need the general definition, okay, a general definition. Okay, so basically, if is conditional, okay, if the u, okay, I gave you a sigma form. If you sigma form, sigma form, the ci sig and ck, so ck k, and it's k is from 0 from 1 to n, okay, n dimensional. If it equal to 0 and k, if it's 0 and conditional, if but not all, but not all ck equal to 0. Okay. If so, then we say that the UK are in all the UK, this set are independent. There are many more than one unit vector, are linearly independent, are linearly independent. So we just go to the extreme, independent. We start, they just a different way of argument, independent. So independent, do you agree? So that is definition. So otherwise, if it's not equal to 0, they are, okay. Otherwise,
what does the scalar ck stand for?
Where is the scalar? CK?
What is that standing for? Is that just
it's coefficient, number.
Okay.
CK is a coefficient. Is a coefficient. This is series. This is coefficient. The coefficient. Okay. So this coefficient, if you, of course, because that makes the reason they put this conditional here. This is conditional. This is conditional. Conditional. Because if all c equal to 0, this equation become trivial. Okay. Okay. If not, so if you just got not, okay. So if this condition not satisfy, you get this equation 0 multiply ui uk, right? I use k because I don't want to use I is confused with this number. Okay, I would prefer use k.
Okay.
So the uk k, the summation of k, equal to 0. Okay. So this means a trivial. In mathematics, this means a trivial equation. It's nuisance. It's not much meaning. Because you deliberately make the coefficient equal to 0. Of course it's equal to 0. There's nothing we can talk about the phasor, right? There's no argument made. and you
Yeah.
can't talk about. So what, I tell you what, that's one of my recent discoveries that, and because they have assumed that the greenhouse effect, because I've been very I spent most of the time to doing this effect. So because this assume this green effect, and the people, the scientists or even NASA scientists have to assume that there will be downward radiation from the atmosphere, and that downward radiation is so strong, actually stronger than the radiation from the sun. So that's why I became very suspicious. I said, so how come you say the clouds, or the clouds can be very can be relatively speaking can be warmer. Okay, yeah, that's
Yep.
okay. But at most, that compared with in Queensland, we know that the solar radiation is much stronger than anything from the clouds or from atmosphere,
Yes.
right? So
Yes.
that's where I get suspicious. But then I realize what they are doing. They are doing this. They are playing this game. Okay, you know what is done here. So they say, it's just side story, but that probably we can
No, this is
discuss.
very
We
interesting.
we can discuss this later. So if you have the equation, okay, if you say a equal to b, all right, okay, that's the question. That's right. Okay, it is right. Okay, it's this question. Okay, they say. You said, oh, it's the greenhouse effect. People argue that, oh, no. It's not A equal to B. It should be written as 400 minus 400. Okay. do you know the Do you know the twist?
Yes.
The twist.
Yes.
So
Yeah.
basically, so A equal to B. Forget about the physical meaning. So basically, that represents the kind of energy balance. Okay. So if you have downward, you must have upward. Okay.
Yeah.
So that is a balance equation. They say, oh no. Let's talk about in addition. So because of the atmosphere here, in addition, then you got 400 down here, okay,
Yep.
and they have another 400 up. You see, so this
Yep.
400 is what they need. Bear in mind, the downward radiation from the sun is is 600. Okay, watt. Okay,
Right.
it's just number. Okay, so that's where I get very suspicious. I say I'm studying for physics for nearly whole my life, right? Since I'm a
Yep.
teenager. That's how come
Yep.
this balance equation, true, okay? But they are realized now they are dealing with trivial things. This is actually very close to zero, can you see? That is called a trivial. This is called a trivial equation. Trivial.
Right.
Okay? It's just
And why
example.
why add in the trivial sort of like why add in the trivial numbers just
Well, that's
to
for their argument. They say that
okay.
the Earth's surface is I just put some dramatic color here. So they think the Earth is warmed up by the atmosphere.
Uh-huh.
Without this warm up, our temperature would be much lower. They became very concerned. They actually, some famous physicists actually in history proposed this idea. We'll talk about him. It's called Fourier.
Ah,
Fourier. That's the first guy.
I've heard of him.
Yes,
Yep.
very French guy. It's very talented. And without him, we don't have FT. We take for the FT. Do you know FT or FFT?
No,
FT
no. I've
transform.
only
FT is
Fourier.
for transform.
Oh yes.
Transformation.
Yeah.
Yes, that is the
The
essence
frequency.
of all the study in physics. Okay, not of things.
Okay.
Okay, so but he does it gets very strange. She said, well, that because the surface temperature is too low without atmosphere, actually so low that is actually is 250. Okay, look, talk about. I want to talk about this later. Okay, if you're interested, we can talk about this. So basically,
Okay.
say this 400 downward from the atmosphere is required in order to raise the Earth's surface temperature by 33 Kelvin or whatever.
Yep.
You can use Celsius, it's the same. Do you understand? So the
Yep.
Earth is so big. So therefore, to raise the surface temperature by 33 degree, just from winter to summer, okay, then
Yep.
the the atmosphere is obliged to put a downward radiation as strong as 400 compared with the solar. Poor
Okay.
guy, this
So
is
it's
solar.
so it's a
This is
spurious
solar.
number.
This is solar. Yeah. So this
Yes.
400
Okay.
makes sense.
Right.
So
Yeah.
the reason I mention this one because I say these are some questions are trivial. Okay, the trivial.
Yep.
So therefore this is very actually that is a way to avoid trivial solution. Can you see?
Okay.
So therefore
Yep.
we put this condition here in order to remind us. So you cannot just talk about this definition if the all coefficients are 0. Okay.
Sure. Yep.
Okay, return to our discussion. So in this case, otherwise, so you can imagine that then that just give you definition of independent basis, independent unit. Okay. Otherwise,
Yep.
otherwise, in other words, if not equal to 0. Okay. So that is
Mm-hmm.
that is to say that the sigma ck and does not equal to 0,
Mm-hmm.
equal to 1, equal to n. Then what we can say, so the set in the set in this the unit vector in this particular set are not are are independent. See, are
Mm-hmm.
independent, dependent. Do you agree?
Mm-hmm.
That is
Yep.
opposite. Okay, this if you fail satisfy this condition, just like the green light. Okay, if you pass the green light, you can count. The camera can catch you, right? And there's
Yep.
two options. You violate the traffic rule or not, dependent. Okay. So that's a big deal. That is has been if you want to pass the exam of linear algebra, this is
Mm-hmm.
type of question will ask you to solve. Okay. Now return to our example. Can we just go to this particular example we just mentioned before? So how about
Mm-hmm.
this U1? Okay, this question here, this example here.
Yep.
Just
Yep.
return to this question. Do you want to try? Do you want to use this criteria, actually two, to see if these two vectors are independent? Of course, if you can prove this independent, they are automatically dependent. You see, there's no middle point. There's no middle choice. So
Right. In this instance, does the so okay, I just want to make sure I've gotten this right. So these are two basis vectors in that the original basis is made up of 0, 1, and then 2, 1.
oh, it's not important.
And
You can talk about this independent without concerning other set. Okay, I think
okay.
are you I just follow your idea. Are you talking about that the let me see, let's draw some diagram here. So are you talking about that you want to refer to these two particular, you want to represent, okay?
Yes.
In doing so, you actually choose a proper, basis, okay? So I
Mm-hmm.
just noticed what you are trying to do. So you basically you choose a proper, say this is one,
Mm-hmm.
okay? So basically you actually trying to represent these two vectors. Do you agree? Yeah,
Yes.
that is another way to do that. That's another way to do that.
Okay.
So basically, so I just make sure I want to know what we are talking about. So basically, you have this. So you got these two vectors, right?
Uh-huh.
Obviously in this case it's a properly based base, but we are
Yep.
talking about these two vectors. Oh, one of them, yes, one of them, yes. Okay, one of them, yes. So basically, but another one is 2, 1. Can you see? Can we
Mm-hmm.
just use the red color to represent the two vector in question? So this is
Mm-hmm.
the two red ones. So this red one, and another
Mm-hmm.
one is we are talking about. Okay, we are talking about the two red color
Mm-hmm.
is a set we are talking about. The origin one would be your choice. Okay, you're trying to
Okay.
represent this representation. Okay,
Yep.
yes, indeed.
Yep.
In the representing of the Voronezh representation, that is x and y, yes, indeed. So that's why the second vector,
Okay.
yes,
So U1 and U2 are not necessarily
the basis.
basis vectors? Oh, they are
No, not
basis.
necessary. So you see, in pure math, people spend a ton of this effort, time to evaluate this general statement. Okay,
Mm-hmm.
they just say they come from very general setup. Okay, You say, well,
Mm-hmm.
if we just accidentally someone give us, a set of unit vectors, we are mathematicians. We can, in principle, to determine
Uh,
whether this guy are dependent or independent. That is
I
the
just,
game.
I just, I assumed that the basis vectors had to be orthogonal, but perhaps not.
Perhaps not. No, that is
Okay.
that is constraint. Okay, that is constraint. After people fail many times, they say, well, if they are not orthogonal, then we will have trouble. Okay,
Okay.
it's good. It's good way of thinking. Say yes, but when we arbitrarily choose a set of
Yep.
unit vectors, we don't have to assume they are orthogonal, or
Okay. Okay.
we even don't have in this case. They even don't have to be unit in the first place. Can you see if you look at the
Yes.
second vector that the amplitude
Two.
is not unit. It's not two.
Yep.
Ooh,
Yep.
it's not two. What is unit for the what is amplitude
Oh.
for second one? So
Oh, the amplitude.
the amplitude for second vector should be equal to square root, say
Oh, right.
y
Yes.
square
Yes.
plus
Yes.
2 square. So what is
Yep.
that? Square root of 5, can you
Uh,
see?
yes. Yes. Okay. Yes.
Okay, return to the
Um.
question. So that is just a related consideration we have to take into account.
Mhm. Um. I still am not entirely sure how I would apply this formula.
Well,
Um.
basically, can we just build this one? So, but can we just build this one? Can we just, because it's only two vectors, can you see? So
Mhm.
what we do, can we just use this definition? So this definition will
Yep.
reduce to 2, k equal from 1 to 2, right? That
Uh-huh.
is
Yep.
ck, that is uk. And in our
Yep.
case, it's so simple. It's just c1, can you see? u1 plus c2.
You
C1,
too.
C2 are coefficient. Okay.
Yep.
So this criteria became the criteria for linearly independent simply become this. So this is
Uh-huh.
equivalent. That is equivalent to the criteria of that. Can you see?
Yes. Yep.
Although this case is much simpler because we choose only two directional vectors.
Uh-huh.
So we basically mathematically can we prove this true? If we could, that's very interesting. Whenever I talk to you, they give me a limit. Anyway, that's very interesting. We'll have 10
Oh, it's
minutes.
okay.
Restart. Okay.
It must be a Sunday thing. I suppose the thing that is tripping me up conceptually is I'm still not sure what C is referring to. I mean, I understand that it's
C could be
coefficient.
constant, could any numbers. Can you see C could be, when we say coefficient, C could be numbers. So for example, what is C can be? So say, for example, this is a coefficient. This is notation we use in mathematics. So
Uh-huh.
C is come from the real number.
Yep.
So what does that mean? So that's, for example, C can be equal to 0.1, okay?
Yep.
Or C can be say 2
Uh-huh.
integer, and C
Yep.
could be -5, yes.
Uh-huh.
So that's all possible. Or could be fraction, or could be decimal, just
So all it would
numbers.
take
Yeah. So it
is
means
one instance of it not equaling 0 to prove that they are
you can choose any possible number
okay.
to see if that satisfies this condition.
Okay. All right. Sure. I can give that a
And,
crack.
but you cannot do treating as this anomalist. to you can't use a zero for both
Okay.
coefficient.
Okay.
Okay, you can't.
All right. Well, let's take the case of 2. So equals 2. Well, actually, let's make that even simpler. Let's go equals 0, 2.
Do you want to try it one by one? So you
Yep.
presumably you assume I notice that you assume this C1 is 1, okay? So you choose
Uh,
C1 equal to 1.
I was choosing C1 equals to 2 and then multiplying U1
Ah,
by
okay.
2.
C1 equal to 2. Okay. I can
Yep.
make sure. I know what to know now. Yeah. So basically, in doing so, you say C1, you have assumed C1 equal to 2. Okay. How about C2?
Yep.
What do you
Sorry.
choose?
Let's call it 3.
3. Okay.
Yep.
We'll do some
Okay.
addition. That become addition of two matrices.
Yes, so that would leave us with this. And that absolutely does not equal 0. That
No,
equals
yeah, not equal to 0.
equals is that is that
So it's
not at
not
all the
equal to
right way?
0. Yeah, you can say it's not
Yes.
equal to 0. It's not equal to 0,
Yep.
okay?
Yep.
So that seems to be that they are linear independent. Do you agree?
Yes.
So you in this particular at least in this particular case, all right,
Mm-hmm.
of this particular case, yeah, you're probably right. You're probably right. But the more general approach, can we first remember this one? Says the general approach is that you have to solve the linear equation. That's because you just doing it by example, okay?
Okay.
So the method two, Euro's method two, this general method. So if we just need to say we just need to C1 multiply 0, 1 plus C2 and that is 2, 1. Is that 2, 1? Yeah. We just need equal
I
to
think I
0,
see where
okay?
this is going.
So how can we solve this C1, C2
I think I know. So that would be,
for all possible values, right?
is that
Yep.
like
Yeah, you got 0. Yeah, on a 0. So you got
um
two linear equation. You agree?
yes. Yes.
What are they?
You have um let me think. We have
So this is a matrix form.
0.
Yes, 0
Yep.
times C1.
What's that? Yeah, 0 C1 plus 2 C2. Um, then we have
Simultaneous
C1
linear equation.
1
Yep, that's right.
plus C2.
Yes, you are correct. So how about the
Mm-hmm.
equation itself? Must be equal to
Oh,
0.
sorry.
Both of them,
Equals
right?
0.
Yeah,
Both
both
of
of
them.
them.
Yep.
So that's what it called. It's different. See, that is matrix form. This is called the simultaneous linear equation. It's called the simultaneous OUS linear equation.
Mm-hmm.
Equation. Equations. Okay. So that is things. Yeah, they're equivalent. Okay. From this, what we can argue from this. So we got 2C2 equal to 0. Okay.
Yep. Yep.
And then
And
what else?
uh,
We got a C1 plus
plus C
C2 equal to 0.
also. Yes.
We have trouble
Uh-huh.
now. We have trouble now.
Yes, we are we is this time for Gaussian elimination? No.
No, not yet. You don't. You see, once a Gaussian elimination is strictly applied for the matrices or matrix.
Okay.
But once we use linear expression, so in the matrix form, we can introduce Gauss elimination method. But in actually, when you're dealing with algebra simultaneous equation, we can simply use algebra. You see. Now,
Okay.
basically, is essentially what does it mean? So they will got a solution. Can you see? 2 multiplied C2 equal to 0. So what is
Mm-hmm.
C2?
0.
Must be equal to 0.
Yep.
So we have trouble here.
And there
And
and
C1
therefore,
can be solved by C2, can you see?
yep.
And because C2 equal to 0, we got it must be equal to 0.
Also 0. Yes.
Yeah.
I see. Okay.
But
Yep.
again, is this consistent with your conclusion? It's not. Can you see? When you choose a C1, see compare with yours, can you use compare
Mm-hmm.
to the method I put this here? It's still confusing, right? Is it consider
Mm-hmm.
when we just consider special case. In this case, is consider that C1 equal to what to 2, right? So
Mm-hmm.
what is C2? Did you choose?
3.
C is equal to 3. And when you're doing that, you found it's not equal to 0, right?
Mm-hmm.
So
Yep.
therefore, we got 2, I'll just do that, that equal to 1 plus 3, that is 2, 1. That will give us. Alternatively, we can just use addition of the matrix, right? You get this, and this is a this is a this is a 2. This is a 2. That sorry, that be plus. Write properly. That should be plus 6 3. Okay.
Yep.
And that would become so 6 plus 5. Okay. Same result,
Yes.
right?
Yep.
So this vector is not equal to 0. Can you see?
No.
So this is not equal to 0 unless all equal to 0. It's very interesting. So this method 1 gives you a scenario that to satisfy this condition, and you have obliged to see both C1 and C2 equal to 0. And in this
Special
method
case.
1, we say we can actually choose any numbers, right? You can choose any number. It seems it doesn't equal to 0. So can we? So what is the conclusion? Can we reach the same conclusion? So that consequence according to definition. So therefore, U1 and U2 are not, right? Are not linearly independent.
Unless C1 equals 0.
Because they are not satisfied this condition. So therefore, U1 and U2 are dependent. Can you see? Are linearly dependent. Can you see? They are not independent. They are dependent.
Yes.
And just return to the definition. Can we use this definition when both coefficients equal to 0?
No.
No. Well, basically, what it does mean, so can we just go to this first question? So basically, you got two vectors. So you got two vectors. So first vectors, so we have the, can we say that is a 2 multiply 1, 0, 1 plus 3. You got two vectors, right? Two vectors, that is 2 minus 1, 2 and 1.
Yep.
So there are two vectors.